Hey guys, this is part one of my walking leg robot project. The basic concept is I want to see if I can develop a walking leg robot. To do that, obviously I don't want to go to the expense of building a multi-legged robot straight up. So what I've done is I've built a walking leg inside the equivalent of a baby's walking frame. The idea is that there are fully rotating casters here on the back, fixed casters on the front, and the robot should be able to kick itself from side to side by sideways movement of the leg to create rotational movement. There are 3 servos here, one for the hip, one for the upper leg, and one for, shall we say, the knee. It's powered by an Arduino, and I'm using just a typical small breadboard here for nutting out the electronics. This is a developmental project, so nothing here is meant to be permanent. I've already changed some things, as you can see by some of the scrap hot glue there. I've already moved some things around, and like here, for example, the thing I moved around was this sensor. My plan was to use this sensor to measure the foot height off the ground, so that as the foot's coming down, if there's a difference, uneven surface, obviously not here on this floor, but theoretically if there was an uneven surface, it would measure that distance and adjust the movement of the foot. But in reality, these I've already been testing this particular one, and these things are nowhere near accurate enough for that to work. So that was basically a waste of time. I will leave it there. I'm not going to take it off. It might still provide some interesting data or useful data maybe at some point. Some of these pins are coming out. Yeah, see, the problem with putting the breadboard on the side like this is sometimes these are coming out, so I need to think about that again. Another problem is that when I bought these servos, because this is a development project, I was thinking of a budget, trying to keep this to a budget, and I found these servos which are definitely powerful enough. They're 15 kg servos, and they're good specs and everything else, but one thing I didn't take into account was the power consumption, and they basically no good. I've got 2 AA's battery type power packs here, and even those 2 are not enough to power the 3 servos. I get a lot of jitter and nothing much happens. So I think I'm just going to have to go online next month when I've got a fresh budget and order some LiPo batteries, 3 LiPo batteries, 1 for each servo. That'll have to wait until next month now. One of the features is that obviously with cost cutting, PVC pipe was obviously a good idea to use, and it's worked out really well. It's made a very simple and strong frame. Another thing is, instead of 3D printing a foot or buying an expensive foot, I've just used a really cheap robot wheel and glued that into the end of the pipe, and that's providing a good grippy foot for this robot. And even though I haven't yet programmed this to walk, I'm still figuring that out obviously, and it's hard to figure out when you haven't got enough power running through the servos, but just that jittery motion of the servos when the foot was down like this, it was just jittering enough that it was actually successfully moving the robot forward. Okay, it wasn't doing it under any programming code as such, but at least the physical design of it seems to be sound. I do have another sensor on the front here, so that as it moves close to objects, maybe it can move around them, but I think I might need 2 more, 1 on each corner as well, to give a wider angle of, shall we say, view. So basically that's it. It is just an experiment, and when I get the LiPo batteries, hopefully not before the end of the month, but if, just have to wait till my next budget comes through, or perhaps get some LiPos and power it up properly. I had considered using a power bank for my mobile phone, but it's 5 volt, and these servos apparently run nicely on 7.4, so I'm going to get some 7.4 minimum 1400, I think, mAh LiPo batteries, just so that I've got reasonable time to experiment with the code and all of that. So that's it as it is. It took me maybe 6 hours to put this whole thing together from beginning to end. All the wiring and everything else. It was fairly simple construction overall, because like I say, this is in PVC pipe, so everything just slots together just like, you know, a plumber can put together pipe really quickly. It was that easy. Yeah, nothing's very complicated. But I do like these servos and the way that they're designed, you know, with the aluminium brackets and all of that. It makes life very practical, and the end caps for the PVC pipe were very good for screwing onto, so it did make the project a lot easier to put together by choosing this form. Anyway, that's part 1, and I can't wait for part 2 to come along. Just have to wait until I can get those LiPo batteries. Unless I can figure out an alternative solution temporarily, maybe a power cable off a transformer or something, just to get the things tested out. I'll see what I can come up with. Until next time, see ya.